Once upon a time, when the solar system was young, there was a wet and warm planet called Mars. And one called the planet Earth. Of all the planets in the solar system, the only two where water might have been in a liquid form at some time in its history, it's only the Earth and Mars. And both were enriched by all the chemicals that are necessary to create you and me. So when we look at Mars, we have to wonder, did life happen there also? If so, what happened to it? If life evolved first on Mars, what's the possibility that life was knocked off of Mars and carried all the way to the planet Earth? Perhaps you and I and everything that's living on the planet Earth are Martians.
Max Q, signatures as expected. RD-180 is nominal. Engine and parameters looking good. Copy that.
We've been searching for Martians since the space age began. More than 50 missions launched. Flybys, orbiters, landers. More than half dead on arrival, if they arrived at all. And so far, there's no sign of life, past or present. The ancient oceans of Mars are frozen in the ground. The atmosphere has been stripped away. Bombarded by radiation, the surface is cold, dry, and lethal. But it wasn't always this way. Billions of years ago, life might have had a chance. The evidence may still be there, and we're still looking for it.
Roger, avionics? Avionics, right 2, 5 by 5. Roger, avionics 2, radio 5 by 5.
August 2012. The Curiosity rover is about to touch down on Mars using a radical new landing system.
Temperatures are stable. Roger that. And good luck. See you on the other side on Mars. 2 minutes entry.
Things are about to start to happen. We all have a lot invested in this. Some of us 10 years of our lives.
We should be traveling around 5.4 kilometers per second on our way to about 5.9.
It's an audacious plan with no margin for error.
The speed, the energy that we have when we hit Mars, that's kind of incredible. 13,000 miles an hour. We show up with enough energy to vaporize the entire spacecraft. And we got to get that parachute out.
This big parachute that we've got, it'll only slow us down to about 200 miles an hour. And that's not slow enough to land. So we have no choice, but we got to cut it off and then come down in rockets. "30 feet off the ground, we let go of the rover. If any one thing doesn't work just right, it's game over.
It happens so fast, it's all over on Mars before anyone on Earth knows whether it worked or not.
It takes 14 minutes for the signal from the spacecraft to make it to Earth. So when we first get word that we've touched the top of the atmosphere, the vehicle has been alive or dead on the surface for at least 7 minutes.
Touchdown confirmed.
Sol 1, first Martian day. Curiosity survived landing. Now she has to survive Mars. Equipped for an expedition that could last years, she could die tomorrow if something goes wrong.
Every day is an opportunity that we must take full advantage of because we never know when the rover's going to stop working.
This is the smartest, most complex robot ever launched from Earth. A 1-ton, nuclear-powered, all-terrain vehicle. Part geologist, part chemist, part photographer. Her mission is to find out whether Mars ever had the right mix of water, energy, and raw material to support life. They sent her to Gale Crater, a basin 3 miles deep and 100 miles across, with an 18,000-foot mound in the middle called Mount Sharp. Orbiters can see clay at the base of the mountain. Clay forms underwater, and it's an ideal environment for life. It can also preserve organic carbon, the stuff life is made of, for billions of years.
This is exactly the kind of place that you want to go to look for organics. And that's a major goal of the mission. You know, where are the organics on Mars?
If there ever was life on Mars, there had to be organics. But so far, they've never been found. This may be the best chance yet. But what Curiosity will find when she gets to the mountain is anyone's guess.
You never know, because when you land a rover on Mars, history shows that many times you can be completely surprised that what you thought was going to be there turns out to be something else.
From now on, Curiosity's team will experience Mars as if they were there, immersed in a world no human has ever seen. Virtual time travelers on a planet that was once very different than it is today.
Mars looks so Earth-like sometimes, it's easy to forget that it's really an alien world. We're exploring from hundreds of millions of miles away and trying to understand what this place was like billions of years ago and why it's so different today. We think there was water here, but we don't know if it could support life. And if it could, we don't know if it did. And if it did, we don't know if the evidence has survived in the rocks. This is not going to happen quickly. It could take years, but we're never going to know unless we try.
They came to explore Mount Sharp, but by chance, they've landed close to what might be an even better target.
That one right there. Those must be the layers of the eroded alluvial fan.
In photographs from orbit, it looks like an ancient delta where a river flowed into a lake. It might be exactly what they're looking for.
If there was ever going to be a lake deposit somewhere at Gale Crater, this would be it. Now, of all the places to search for habitability and a preserved environmental and organic record, a lake is a really, really good place to look.
It could take a year to reach the clay at the base of Mount Sharp, 7 miles away. The possible lake bed is closer, but in the opposite direction. And if it doesn't pan out, it's time lost forever.
There was this discussion about whether we essentially drive backwards from the destination, right, the Mount Sharp, and go to this really intriguing area, possibly formed by a river, although we didn't know that.
It may be the crown jewel of what we're searching for. It may be the perfect place.
It's a gamble, but they decide to take it and head for the spot they call Yellowknife Bay.
Everything is a gamble when you're operating a rover on another planet. At any moment, something completely unexpected could happen and take out part of your rover or the entire thing. Everything is a gamble.
Curiosity's team has spotted what looks like a dried-up lake bed just a few hundred yards from where they landed. A place that might once have supported life. Flat out, she could get there in a few days. But the engineers have to make sure that everything on the rover is still working after the rough journey to Mars. And that will take months. So for now, the orders are, take it slow. Before launch, it was a different story.
We've dropped it from towers, we've driven over rocks, we've driven it out in the desert, and it just does it. It's an amazingly capable vehicle that can do an order of magnitude more than we command it to do every day.
Long before landing on Mars, Curiosity had to prove herself on Earth. But in the Mojave Desert, it's hard to get the full Martian experience.
We have to deal with all these different things that are unique to Mars. Gravity's the biggest one. Mars gravity's 3/8 of Earth's gravity. So we had to build a whole nother rover that weighs on Earth what Curiosity weighs on Mars.
It's really fun to, like, every once in a while, kind of leave the office environment behind and come out to an environment like this and see what the real rovers are going to be doing on Mars.
That's what we should do, is dig in all 6 wheels, have it sink down so they're completely embedded as though it were in an avalanche, and see if it comes out.
We're potentially burying the side wheel, the middle wheels.
Let's get it really stuck.
Okay.
Yeah, that's what I'm trying to do.
You know, my dad said I was always going to become a ditch digger, and maybe he was right. We could shovel more in there, but I mean, it's up to its axle, right?
We're really starting to sled now. Look at it go. Yeah, once the wheels drove over the mounds.
By the way, what I'm learning here is that it's really hard for this thing to get stuck.
Curiosity makes it look easy on Earth. But on Mars, simple mistakes can be fatal.
2-minute margin before our computed downlink of 8.5 megabits.
We are a little bit power constrained.
We have landed a gigantic, complex machine hundreds of millions of miles away, and we're operating it by remote control, and we have to treat it very gently. The rover does things each day, and then at the end of the day, that data is transferred down to the Earth. The people on the ground look at what happened the day before, and then they begin a breakneck near sprint trying to figure out what the commands for the next day should be.
We'll be analyzing the rest of the sequence execution today, and then we'll get into the briefing.
You know, there's not a lot of people who can say that they've commanded a vehicle on the surface of another planet. And once you have that experience, you get quickly calibrated to risk. The gravity of what we're doing isn't lost on us. And once you hit enter and you send those commands to Mars, there's nothing more you can do.
Late in the day, there was this object seen in one of the images following Yester Sol's activities.
There's a problem on Mars. An unidentified object sitting on the ground in front of Curiosity. The first pictures aren't sharp enough to tell what it is, but people are worried. They just finished vibrating some sand through the sample processing turret to clean it out. And it's possible that a screw or some other piece of hardware came loose.
This was the last image of the day, right after we had scooped and vibed. We had this perfect scoop full of dirt, and at the last minute we just started discussing that whole thing down there. We can't rule out that that's a piece of hardware that fell off from all the vibration we've done.
So the team was super excited until we saw that little glinty thing down there. That's about 2-3 millimeters across. So a very small thing can hamper your entire day.
They have to vibrate the turret to prepare samples for the science instruments. And if it's falling apart, that could cripple the mission. It will take time to get better pictures. Until then, they work with what they've got.
See, it's a glint.
We looked with the left eye mass cam, and you see this very shiny object that looks like a screw, but they got it with the chem cam. And when you zoom in, that does not look like a screw when you get close up, which is
that's a great
fantastic news.
Finally, with a better picture, its true identity is revealed. A flake of plastic insulation.
Like most likely suspect is this kind of stuff. These kind of crimping materials, and you can see if you were to try and cut this off a wire, you would end up with a piece like that.
Not a problem.
It's not an
Yeah.
But no glitch is too small to ignore on a $2.5 billion mission. Now they can deliver the first bit of Martian soil to the heart of the rover, the organic chemistry lab called SAM, to see if it survived the trip to Mars.
Here we are, the first scoops of this soil from Mars are getting dumped into SAM. A lot of pressure, a lot of eyes on this.
SAM will search for Martian organics, the building blocks of life, by heating up powdered rock and soil and analyzing the vapors. They don't expect organics this time. It's just a test, and it's working.
We are all so incredibly thrilled that we have data. SAM is working.
Good so far, but no one is prepared for what happens next.
Oh my God, I mean, we got the data back and there were hydrocarbons everywhere. Organics were just popping from this sample. We all thought this would be a really hard thing, finding organics on Mars, but we've hit it on the first try. It was unbelievable.
If this is real, the potential for life on Mars is greater than anyone ever imagined. If it's real.
All this data's coming in, and you see all the different kinds of gases that are coming out of the sand, and one of them is telling you that there might be organic carbon on Mars. And the first thing I think is, gotta be careful. You know, there's always a chance that we might have brought some organics from Earth that might contaminate the measurement.
It was like, this was too good to be true. I mean, we can't have hit it right here on the first sample. Something else must be going on. And in fact, something else was going on.
Built into the SAM instrument are a few small vials called wet chemistry cups with organic compounds sealed inside, intended for controlled experiments later in the mission.
One of these wet chemistry cups sprung a leak. We don't know exactly when or how. It could have been during the vibration on the rocket, during landing on Mars, but nevertheless, some of this vapor escaped inside SAM.
The organics they're seeing here came from Earth, not from Mars.
I mean, I gotta be honest with you, I felt terrible. Mainly because, I was one of the key people involved in putting this experiment together, the wet chemistry experiment. I mean, you go to painstaking efforts to try to clean your instrument, make sure there's no terrestrial organic signature, so that when you go to Mars, all you see is Martian, right? You don't see stuff that you brought there.
This is a problem they can work around, but it's complicated by another problem. Something in the sand that's native to Mars. It's called perchlorate. It's explosive, and it's triggered by heat.
Now, the problem that poses for us is that the way we analyze our samples is by heating them up in an oven. So what I'm going to do is take a little sugar and put it in a spoon. That's our organic matter. The sort of thing we would love to be able to detect on Mars. But in addition to the sugar, now comes the perchlorate. Now that's the stuff that we think is causing the problem on Mars. Now we're going to do what we would do on Mars to detect that sugar, which is heat up the sample. Well, this is exactly what's happening on Mars. The perchlorate is reacting explosively with the organics, releasing this oxygen that burns the organics. It's not as dramatic as we just saw here because the concentrations are much higher here, but it's certainly not a way to detect sugar. All we're going to see is smoke.
The explosive reaction scrambles the identity of whatever was in the sample to begin with, making it that much harder to sort out real Martian organics from contamination.
It's easy to get fooled by Mars. Mars is indeed an alien place, and so we hit unexpected problems. Perchlorate was the big one. I would be surprised if it was the only one.
Almost 4 months into the mission, Curiosity finally reaches Yellowknife Bay, a possible ancient lakebed 500 yards from where she landed.
When we rolled down into Yellowknife Bay, we realized we had found something really good. We looked around and we saw this kind of a rock that was fractured, it had veins in it. We've got a lot of evidence for water here.
With its laser, Curiosity zaps one of the veins, and from the puff of smoke, can see that this is a mineral with water inside.
And it was just one more piece of a story that says there's a history of water here. And where there's water, there's a potential for life.
We're sitting in the right spot. It's just a matter of picking that safe spot to drill and let's go.
Curiosity's drill is a crucial but potentially dangerous tool.
Every time we take the robotic arm and we put it in contact with the surface of Mars, we all get a little nervous because the last thing in the world you want to do is have the rover slip a little bit and break something on the arm, break an instrument off, break one of the joints. And doing a drilling operation is just that, even more so, because you're now putting this drill bit into a hole where if the rover moves at all, you have the likelihood of jamming that bit or snapping that bit off. Yeah, I worry about it a lot.
Another month goes by. Then finally, they're ready to drill and find out what this rock reveals about the story of life on Mars.
We landed in August. So here it is now, January, and we're starting to drill this thing, and you're wondering all the time, boy, I hope this rock is good because it's taken a long time to get here.
Sol 200, overnight activity will be at Sammy GA Pass. Here, it looks like we're seeing a flood of single bit errors.
After 200 Martian days, without warning, Curiosity has stopped taking orders from Mission Control.
Well, I got an email from one of our engineers saying, folks, we need to meet. Something's not right. I come to the meeting, and the first thing they tell me is, hey, Rob, the rover didn't go to sleep. I go, what?
Here is where we see a shutdown dispatched, but it doesn't take place.
I said, Rob, it's worse than that. It stopped taking pictures. It stopped collecting science data. It stopped doing all sorts of things. What? How can that be?
Computers basically decided it's not going to execute any more commands. We knew that we had a problem, but we can't correct it because we can't send commands in because it's going to ignore them.
This discovery, 200 Martian days deep into the mission, sent chills of fear through the engineers.
Curiosity had just finished analyzing its first Martian rock, and the scientists were on the verge of confirming the discovery of an ancient lakebed that could have supported life.
The science team, had a huge finding. And I remember seeing through the glass that John was given the briefing about this finding. And going through my head was, I hope this isn't the last finding we have because the rover Curiosity is in real trouble at this point.
Something funky is going on with the file system, and the funkiness is causing other things to get torpedoed.
I was worried. What would happen if Curiosity was not able to recover? We were that close to being able to put the nail in the coffin about our first order goal as a mission, which was to discover a habitable environment. And, that's all about to slip through your fingers.
So we're actively trying to figure out what exactly is happening and how much danger are we in the upcoming events. something going on with the file system, right? We had an issue with that earlier.
It looks like a damaged memory chip, and something, perhaps a software bug, is preventing Curiosity from switching to its backup computer.
This is crazy. I mean, this is not how we designed the system. We're not in constant contact with this rover. The rover has to be able to discover its own problems and fix itself. We have two computers on board. We have the A computer and we have a B computer. You can think of them as a pilot and co-pilot. And we have an alarm system that allows the co-pilot to wake up and take over. If the main computer, if the pilot has a problem, well, that didn't happen. This pilot stayed in charge. It kept resetting the alarm. It's like, I'm sorry, Rob. I'm afraid I can't do that. I'm fine. I'm fine. Don't bother me. I'm doing everything you asked me to do. I said, no, you're not. You're not doing any of the things we asked you to do. This vehicle had lost its mind.
What currently is going on the rover?
The state of charge for the battery showing 63%, which is consistent with the fact that the rover is not shutting down.
Time is now the enemy. If they don't act soon, Curiosity could stop communicating altogether. A devastating blow to this mission, and perhaps to future Mars exploration.
Things are getting desperate, and we don't have much time. So what can we do?
The computer on Site A has a problem. We don't think the computer on Site B has a problem. The issue is getting the spacecraft to change to Site B. It's not going to let us do it. It's going to ignore us. We have to force the rover to swap to the other computer.
That's a really complicated thing to do. I don't think...
Normally, they'd run tests before taking such a drastic step. But they can't afford to wait. Simply put, they have to knock out the pilot and hope the co-pilot takes over. It's risky, but if they wait too long and Curiosity shuts off its radio, they could lose contact forever.
As the minutes and hours go by, there's greater and greater fear that we won't even be able to get a command in, let alone have it executed. If we can't get commands in, then that's lights out.
We have to do this action. We have to swap to this other computer.
Rather extreme step. People have to stop and think instead of trying to panic to get a command in. We were doing this all in a big rush in a few hours, and that's a reflection of how worried everybody was, that if we didn't do something soon, we wouldn't be able to do anything at all.
So we look to each other and say, yeah, it's the right thing to do. Just do it, because if we don't, we may have no computer. We may not have a rover in a few hours.
Flight Ace. Go ahead, Ace. Okay, transmitter's on.
And so we went ahead and sent the commands.
Hotel Delta Whiskey _00034, and waiting your go. Ace, flight, your go to commands. Copy. And radiation's active.
What happens is that when you do such a thing, you lose communication for a period, and then you look to regain it.
But we're going to be watching here in the middle, and when we get our signal from Mars, we should see a little spike show up somewhere here around the middle.
And so we're standing here watching that screen. We're waiting for that signal to appear. And normally these things appear within a few seconds of when they're supposed to. I'm thinking maybe 5 seconds, 10 seconds, nope. 20 seconds, nope. A minute, oh my goodness. This is a lot longer than it should be. Minute and a half, 2 minutes, 2.5 minutes, 3 minutes, and we still don't have the signal.
6-3 MSL Ace. MSL Ace 3. Just want to confirm you're not seeing anything in your FFT. We confirm we are within the FFT display. We don't see any signal coming. Copy.
If we can't even get a command in, there's no hope of regaining control. So we're past the 3-minute mark and the signal still isn't there, and we're starting to look at each other. Everybody in the room is, I can see their hearts sinking. But about 3.5 minutes after it was supposed to come down, the signal appeared.
Our
signal was sticking up 5 dB out of the noise. You can see it, but it's real small. It's only that big.
A freak event. A damaged chip triggered a software bug that almost killed the mission.
We have a nice, easy number to remember. The Sol 200 bug.
Yeah.
Oh, yeah.
Something that nobody had foreseen. Nobody discovered it in test on the ground. And boom, there it is. It took 200 sols for it to occur. There's always these fears that there's still something out there that we haven't found out about. An unknown unknown. And once in a while, it's a killer.
The crisis is over. Curiosity is back at work. She's discovered a dried-up lake bed, a place that once had everything life would need to survive. Now, the search is on for the building blocks of life itself, organic carbon. Curiosity's drill has turned up something never seen on Mars before: gray powder inside red rock.
On Earth, we know that gray material, dark material, is what we find underground when it's organic rich and biology rich. If there was going to be organics on Mars, I was sure this was going to be it. This was going to be pay dirt.
A bit of the powder goes into the laboratory, gets cooked, analyzed, and when the data comes back,
No obvious signs for organic carbon. And we were stumped. You know, where is it? We thought it might be there. We're still trying to figure that out.
Even if life never happened on Mars, there should be some carbon. It arrives every day in space rocks. Something must be erasing the evidence, and the culprit may be the explosive Martian chemical they discovered in the ground. Perchlorate can burn organics, but it needs a trigger, like heat, to set it off. On Mars, the trigger could be radiation. With its thin atmosphere, the surface is baked by cosmic rays. That alone can damage organics, but perchlorate in the ground could make it even more destructive.
I think what's happening is that the radiation is sort of acting like the heat in our ovens. It's activating the perchlorate. In the oven, it's activated by heat. In the soil, it's activated by radiation. Either way, it's destroying the organics. There may be a little bit left. There may be the ash left after the fire, and maybe we'll still find that.
They drill another rock. This time, they do see organics, and they're different from the contamination that fooled them once before. But are they from Mars or from Earth?
There is a possibility that we have Martian organic carbon, but it's not what we ever expected. And so we need to be sure. We need to be really sure that it is what we think it is before we make some grand claim to have found it. It's where we are.
With a sample stashed on board for more analysis, Curiosity finally moves on from Yellowknife Bay, headed for the original mission target at the base of Mount Sharp, 7 miles away. For the next year and a half, the rover navigates treacherous Martian terrain. Along the way, her instruments pick up small whiffs of methane gas in the atmosphere, but not enough to tell if it was produced by life or some geological process. Back on Earth, they're still trying to prove that the organics they saw in Yellowknife Bay came from Mars, not from Earth.
We had to run hundreds of experiments to convince ourselves that it really was Martian. We pretty much ruled out that this was some sort of contamination, but we still weren't quite sure, and then we got extremely lucky on Mars.
The breakthrough comes as a surprise, 5 miles from Yellowknife Bay, near the base of Mount Sharp. They drill and find no organics, which would be disappointing, except this time it proves that the instrument is clean. What they saw back in Yellowknife Bay is no longer a question. They have found organics on Mars.
Oh my God, we found it. This could be from life. We don't know that yet, but we're certainly going to do our best to find out. This is organic material in a lake bed environment that has been there for likely millions of years. This is a huge discovery. People have been trying to do this for decades, unsuccessfully, but we did it. We've delivered. We found the Mars organics.
Now we know that Mars once had everything life would have needed. We know the evidence can be preserved in the rocks, and if it's there, we know how to find it.
To planetary scientists, this is already a home run. However, what you and I want to know was, okay, so it was habitable, but was there life there at some time? We do not know the answer to that question. That is what the rest of the mission will be about. Curiosity is still an unfinished story. The next step, and the next step, and the next step is what's important. We will never stop asking the question, are we alone?